everyone. I am very sorry I'm not in the lesson today, but what I wanted to do was to just record a quick video that tells you what you're doing. You're using the wonders of the circuit builder today. Oh wow, fantastic. This is an interesting thing. This is what Google thinks I want to know about. Last minute holidays in the weather tomorrow. What time is it in India? That's an interesting question for it to ask. We're going to look. I'm going to send you the link for this, but you are using this thing. It's called the FET Circuit Builder. Okay. If you type that into Google, you'll get the circuit construction kit. So we can load that up and load up. We get this up. Probably rings a bell, and we get this wonderful FET interactive simulations thing that's loading up. Now, what we're after using is the lab. We're not after the intro. We're getting a bit more complex. Physics is getting more physicsy. So we're after the lab. So we're after this, which looks almost exactly identical. And we are going to look at the behavior of a light bulb. But this is a simulation. And the light bulb here, standard one, doesn't work. We need to open up the advanced tab, and we need to say, I want a real bulb. So we tick that, and suddenly a real bulb appears. So this is the thing we're going to investigate. We're going to investigate that in the way that we, very similar to the way we investigated the fixed resistors, but just using the simulation, obviously because I'm not there. So we're going to set the circuit up. We need our power supply, so we're going to use a battery. And we are going to do this as if we were doing it in the real world. So we're going to, the results you're going to get are going to have a bit of scatter in them. We're going to have a switch. Why not? We are going to have an ammeter. Let's put an ammeter here. Okay. And we're going to have our voltmeter. And annoyingly, they make this giant voltmeter. It's really irritating to make a giant voltmeter. So let's move this up here a little bit. There's our voltmeter. That's what we're going to make. So let's make our circuit. So do that. Do that. And let's get it up to there. There's our ammeter. Wire to this bit. Wire to this bit. And wire out. And final wire. Let's make this all nice and lovely. There we go. Close switch. And we've got our bulb, which is lit up. Okay. And we are using what we call a real bulb here. We're not going to play with any of these other settings. We're not really there. And we stick our voltmeter. Oh, I've forgotten something. No, this is not the right circuit. Ugh, I've missed out my variable resistor. So to have a variable resistor, I'm going to stick a resistor in here. That's what we want. And then we case that. So what we have is, this is our voltage reading. Got our battery. We're going to change our battery. We're going to make our battery 20 volts. So we use the table there, make it a 20 volt battery. We've got current, we've got this, we've got our variable resistor. So this is the resistor we can vary and we can move it up and down. And essentially the way, you can see from the amount of light that's come out, this is essentially the dimmer switch idea. Okay, if the resistance of the variable resistor is really high, okay, then we've got a very small current, we don't have a very big voltage, we don't have a very bright bulb. If we go all the way to the other end, so you have zero resistance, we now have all 20 volts in here, we've got a current of 0.85 amps, and we've got a very bright bulb. Okay, so the idea is that we're using the variable resistor to get a different series of values of voltage and current. And what there is a little sheet that will explain the layout of the experiment. Is what you've got to do. But you're going to change the value of this variable resistor by going down in units of 15. Okay, so we're at 120. We go down to drag it down. You go down to 105 approximately, and then 90, and then so on, so on, until it's down to 0. And you're taking readings of voltage and current. Okay, and for each value you can calculate the resistance of the bulb. But then at the end, what you're going to be plotting is you're going to be plotting a graph of the voltage on the x-axis against the current on the y-axis, and drawing the curve of best fit that you think best fits. Do remember that when you have your results, that 0 and 0 is a result you have. Okay, when there is no voltage, there is no current. do remember that that is a thing that exists. And that's kind of the experiment. So there are Chromebooks available. So get a Chromebook, load up this. The instructions are on the sheet, and we will discuss your values and what we get and why we get those things tomorrow. Oh, the switch is closed. That's very exciting. Okay, I will see you tomorrow.